Hi, I'm Mr. Huber, and in this video I would like to talk about the vertical stretch. Now look, let's start with something we know very well, the quadratic. Well, 1x squared, so the original parabola. So let's just do 2x squared. So what happens? Let's go to 1 here. What happens as I do that? Well, it will be stretched apart, okay? You see, a came up from 1, 1 to 1, 2. Stretched apart. As I go down, let's go to 0.5. It will be a vertical shrink. So it came down from 1, 1 to 1, 0.5. So A seems to be a vertical stretch. Well, clearly, as I go for a negative number here, it will be a sad parabola. Okay, let's think about sine and cosine in this case. So what's going to happen as you do the same thing for sine and cosine? Let's put this back to 1 and switch this off for the moment. Now let's have a look at sine. This is the normal sine function. Let's switch off A. Now look what happens. If I move A will be stretched apart. This one goes up, the max goes up. As I move it to, let's say, 3, the middle line is at 0, but your highest point will be at 3 and your lowest point at -3. This is called the amplitude. So for a sine transformation, when you multiply everything by a number, it will be a vertical stretch or a vertical shrink, and we're going to call that amplitude. So if I go down to 0.5, look, it will be a vertical shrink, like with my parabola. As I move it up, this will be a vertical stretch. Why do I have to put the A there? Because otherwise you would think that your parabola is just getting narrower or wider, if you want to. But it's not. It's a vertical stretch. You can clearly see that at 1, A goes up and down. You don't have to do that for a sine curve, because you can look at the max here and you see as I move it up, your max will go up, and as I move it down, your max will go down. So what happens if I put A on a negative value? Well, that's clear. It's just a reflection in the x-axis. So this is, in fact, a sine function which has been reflected in the x-axis. Again, I don't have to put an A there, a point A, onto my sine function, because it's not necessary. You can just look at the max here. Very easy. Let's put it back to 1. Here. Oh, it's terribly fiddly. It's horrible. Good. Now let's do the same thing with a cosine function. Let's switch this off. It's pretty clear what's going to happen. As you go up, you stretch it apart. It's a vertical stretch. As you go down between 1 and 0, it's a vertical shrink. So my max is, instead of being at 0, 1, it's now at 0.5. Or if I shrink it down even further, now my max is at 0.3. 0.3. So I think the amplitude is pretty clear, a vertical stretch or a vertical shrink. It's very rare that we have an amplitude which is negative, very rare. But this is in fact just a reflection in the x-axis and a multiplication by 2. Same thing here for the quadratic. Look, let's switch this off. It's a reflection in the x-axis and then a vertical stretch by 2. So I think amplitude done.